Great, well thank you, and thanks for this opportunity to come to the workshop. I have been asked to talk about hydrothermal activity in the Indian Ocean, and unlike many of the talks that were very laden today with a lot of good data that provides a good foundation for understanding circulation in the Indian Ocean, what you're going to find is that we know very little about hydrothermal activity. I'm going to start off with this compilation that was put together by Interridge of the known and inferred hydrothermal sites of activity in the Indian Ocean. Now, there's a lot of dots on this map, but I will tell you that the yellow dots are all inferred sites of hydrothermal circulation based on either looking in the water column for chemical and physical signals of hydrothermal activity, or some of them are from actual images or dredges in the areas. So within the Indian Ocean as a whole, on all the ridges, we have about 90 to 100 sites that have been identified as possibilities. There are only 9 actual sites, of which there are only 5 active ones and 4 inactive ones that have actually been seen or actually been sampled. So the first message to you is we know very, very little about hydrothermal activity. And as Henry pointed out, it could be a really important process in terms of cycling of elements between the lithosphere and the hydrosphere. So there's about, as I said, 90 to 100. There are, oops, sorry. This is fussy. You did tell me. There we go. There are a number of inferred sites down in this area of the southwest Indian Ridge, and as Henry just pointed out, this is an ultra-slow spreading ridge, and some more up here. On the intermediate spreading central Indian Ridge, there's a number of them, and I'll come back to the active ones in a moment. There's 3 sites on the Carlsberg Ridge, and then there's a lot of inferred sites down on the faster spreading southeast Indian Ridge, but there have been there's been no sites actually identified. So what I'm going to do is I'm going to concentrate on the sites that we know about. As you will see, we know a little bit about most of them, but not much. And I'm going to start down on the southwest Indian Ridge, because that's where Henry was just talking about. And on that ridge, we know of 3 inactive sites that I will just describe in a moment, and 1 active site that brings us back to Henry's point about the importance of spreading on ultra-slow spreading ridges. So the 3 inactive sites that we know about are these. The first one, Mount Jourdain, was discovered by the Japanese in 1998. It is on a volcanic segment of the ridge, so it's not the segments that have large amounts of mantle rock showing. It sits in the graben on top of an axial volcanic ridge. It's a fairly small site, and it has small chimneys and mounds. What is different about this site is that unlike most basalt-hosted hydrothermal systems, the chimneys themselves are quite rich in galena, which is a lead sulfide, and also in lead arsenic sulfur salts. The chemistry of those chimneys is a little different. It looks more like the chemistry of the types of hydrothermal systems you see on sedimented ridges or that have been impacted by continental crust. However, there's very high silver and gold that are associated with those lead arsenic sulfose salts, and that is thought to be due to a later process of hydrothermal circulation that actually remobilized a lot of the metals and brought them up to the surface of the structure. The second one I have here was an unnamed site that was found by the Chinese in 2008. It has recently been referred to as the Breakbridge site by the Japanese. It is also in the center of a magmatically active segment. It's a very small site. There's a description based on a sample collected with a TV grab, but there's nothing else known about it. And then the third one is the Jade Emperor Mountain, where there is very little information except for a couple of samples. There has only been one abstract ever written about that site. As you can see, it's much shallower. Given that it's called a mountain, my suspicion is that it's also on a volcanically active segment. Now, the one site that is active that we know of on the Southwest Indian Ridge is the Dragon Flag or Longqi hydrothermal field that is associated, as Henry was describing, with an active fault that is bringing up mantle rock along a fault to form what are called oceanic core complexes that are exposing lower crustal and mantle rocks. This is a seismic experiment that was done just a few years ago, and this structure is a structure called a detachment fault that is a high-angle normal fault that is pulling crust or lower parts of the crust up and exposing them on the sides of the axial valley. However, this particular site appears to lie on the hanging wall, which is this part here of this detachment fault, and it is very much like the Tag hydrothermal area on the Mid-Atlantic Ridge. It's a very similar structural setting, and the area is very active. It has big chimneys that are up to 20 meters high. There are mounds of sulfides there, and the chemistry was just sampled for the first time 2 years ago. And I'm not going to go through the chemistry, and I don't expect you to either, but you can see that the temperatures are quite high. These are quite active chimneys. The chlorinities are higher than seawater, which indicates that phase separation is going on at depth. And as usual, these samples are very rich in the transition metals. This is the type of chemistry that you find at hydrothermal vents that have reacted with volcanic rock. So clearly, this signal is based on the fact that this is actually sampling or altering mafic rock rather than ultramafic rock. Okay, so before I leave the Southwest Indian Ridge, I will say that just recently there was a French cruise to the Southwest Indian Ridge that I have been told has found another hydrothermal site that's a lower temperature site, very much like the Lost City site on the Mid-Atlantic Ridge, which is an ultramafic hosted system. I don't have any details of it. There's nothing published on it yet. But my suspicion is that there are likely to be a number of those types of systems on the ultra-slow spreading ridge. I'm going to move on to the Central Indian Ridge, where this is the area that perhaps we know the best, although that's not saying very much, I'm afraid. We have 5 sites here, and I'm just going to show you quickly their settings. We have 2 active sites up just east of Rodriguez Island that are on crust that is influenced by being proximal to a hotspot. And then we have 2 sites down here near the Rodriguez Triple Junction that were discovered in 2000 and 2001. Oops, sorry, I've missed one. Yeah, okay. The one inactive site that we know about is called the Mesto Site, which was found by the Germans in 1993. They actually named it the Sonne hydrothermal field, but there are actually 3 areas, and it has been renamed the Mesto Site. These are areas with big mounds of sulfides that are degrading very rapidly. They've got small, old chimneys on them. The copper minerals have all been oxidized, and these deposits are slowly being covered up by pelagic sediments. The active ones that we have are these 4, and I will just talk quickly about each of those. Up near Rodriguez Island, we have 2 sites that were found by the Japanese in 2009. One is called the Dodo field, and the other is called the Solitaire field. You will notice if you look at this map that there is a difference in the tectonic setting of these two. Dodo is in the middle of an axial valley on a volcanic graben. Solitaire sits up on the western wall. And so we've got 2 very different tectonic settings for those two. Oops, let me just go back, sorry. So let me first describe Dodo. As I said, this is it's actually sitting on a lava flow that is a sheet flow that you can see here. It has very small black smoker chimneys that are not particularly, or were not particularly active when it was found, although some of the fluid coming out was over 300 degrees. And those chimneys are aligned along cracks in that lava flow. And there's also a lot of diffuse water coming out of that lava flow. The Japanese went back there in 2013 and could not find any high temperature activity. So clearly this may have been a very localized response to that particular volcanic episode. The Solitaire field, as I said, sits up on the western wall of the valley, valley, and it is much bigger. The other one is quite small. This one covers an area of about 50 meters by 20 meters, and it has chimneys, black smoker chimneys, that are up to about 5 meters tall and are still fairly active. And I'll show you the chemistry in just a minute. The other 2 areas that we have are also in that same setting, up on the walls of the Rift Valley, which raises the question as to where is the heat source to actually organize fluid flow in these areas. The Edmond field up here was found in 2001 on a cruise that I was on with Jason. And the Edmond field is the biggest of the 4 fields. It again sits up on a protrusion in the valley wall. It has large chimneys that are very well organized, up to about 35 meters tall. They're very hot. They are spread over an area of about 100 meters by 100 meters, so it's a fairly big area. But as you will see, it does appear to be basalt hosted. And finally, the Kairai field was found in 2000 by the Japanese. It was described as sitting up on the valley wall, which it is. But you will notice that since then, this concept of detachment faulting and oceanic core complexes has evolved. And as you can see, these named areas on this map are actually all mantle rock that is exposed. So it could well be that Kairai is associated, again, with this detachment faulting and exposure to other types of rocks. And if we look at the chemistry very quickly of these, as I said, Kairai might well have the influence of mantle rock associated with it. And you can see a number of things here. These ones are fairly typical of basalt-hosted system, although Solitaire has a slightly higher pH, which is very typical of hydrothermal sites that have slightly lower temperatures. The other things that I'll point out is the chlorinities. They obviously vary all over the place, again, due to phase separation. And the other thing I'll point out is particularly iron, and it is also true for the other transition metals. You see high variability in the iron, very high levels associated with the ultramafic host influenced system. So in summary then, hydrothermal activity appears to be widespread in the Indian Ocean. We don't know how many of those inferred sites are separate, individual, discrete areas, but that would certainly be something very interesting to know. There is considerable diversity in the tectonic settings. We have on-axis sites, on Rift Valley wall sites, associated with detachments, not associated with the detachments. So we've got a range of different types of systems. There's variation in the substrate host rock. Dodo and Solitaire, with their high potassium chloride ratios, show influence of hotspot-influenced mid-ocean ridge basalt. There's some on normal basalt, and there's, as I said, some affected by ultramafic rocks. The vent fluid chemistries that we've seen so far, which as you can see is not many, because I think I showed you almost all the data, are similar to those seen at other mid-ocean ridge systems in similar settings, with the fundamental regulating processes still being fluid-mineral equilibria and phase separation. So what are some of the questions we might consider in the next few days? Some of these questions are very big, and a single cruise is not going to answer them, but they're the sorts of things we can think about as we're talking about the geology of the Indian Ocean and what might be important. So what is the abundance and diversity of hydrothermal systems in the Indian Ocean? What's the contribution of elemental exchange from hydrothermal systems in local and global biogeochemical cycles? How do fluids link the subsea floor and the water column biogeochemical processes? And what is the resource potential of both active and inactive mineral deposits? As of now, the Southwest Indian Ridge, the International Seabed Authority has issued a lease and a license to China for exploration on the Southwest Indian Ridge. The same on the Central Indian Ridge, there are licenses to India and Germany. So there's a lot of interest in this particular question. So I think that that is something that might be appropriate for us to consider over the next few days. So thank you very much.
Thank you, Susan. So again, let's maybe take one quick question, Jim, while we're switching over to the parent car.
So on the Japanese geotraces meridional section,
Yep.
They found a fairly big iron plume in the deep ocean that seemed to arise from one of those features.
Right.
But they also saw a significant aluminum plume. And aluminum was also one of the big three elements that was seen in the U.S. geotraces zonal section across the East Pacific rise. What does that tell you? Because aluminum is not an element that was on your list, and yet it seems to be associated with these features.
Yeah, that's really interesting, and I don't know the answer to the question. Very often in these systems, during the water rock reactions, aluminium is relatively immobile. So I'm not sure where that's coming from. So I don't know the answer to that question.